So, welcome to this module on file systems 2. We covered some basics of file system in the previous module with lot of inputs that we tried to give from a security perspective. We will see more about that in this module. Now, one of the important things is that when we looked at a file control block, there are a lot of details about the file, its name, when was it created, what are the permissions, etc. The next thing was how the file is allocated, and that is very important, because a virus can basically go and look at this allocation, and if it can go and tweak this allocation, then you may land up with lot of problems. So, from an information security perspective, how the file is organized. So, I have say a file with say 2 megabyte large file, how is it actually stored in the disk, right, and that is what would be the subject matter here, and understanding of that would be also very important for you to go and look at how some viruses can basically go and meddle with your file system, right. So, there are 3 ways of allocating. So, I have 2 MB, how will I store it in the disk, where will I store it in the disk. So, when I am creating the file, the operating system will allocate space. So, there are 3 ways of allocation, one is contiguous allocation, another is linked allocation, third is indexed allocation. We will see all these 3, the pros and cons of this. Okay. Again, these are basic operating system concepts. Why I am revising it here is because these would have very serious security implications. Understanding of this would be useful and important for you to understand certain viruses. Now, what is contiguous allocation? So, disk basically consists of blocks. Each block, let us say, can handle up to 512 bytes, sometimes even 1024, 2048, etc. Now, suppose I have a file of say 100 blocks, these 100 blocks should be one after another, right. So, that is very simple. So, 100 blocks should be just behind one after another. So, this is called contiguous allocation. Now, what are the drawbacks of this contiguous allocation? The drawback of this is that later I want to increase that file. Today you have a file of 4 MB, say 2 MB or 4 MB. Tomorrow I am going to add some more records to this. You have to keep editing the file cannot grow, because you make one contiguous allocation of 4 MB, then immediately the next file will start. So, you need contiguous allocation. So, that is why if I now go and change the file, then the operating system has to completely remove this 2 MB and find another space which will have 3 MB and now copy this there. So, this becomes extremely complex for the operating system to maintain. So, contiguous allocation has this problem, but the good thing is that if part of the file gets erased due to some virus, etc., the remaining part will be intact. So, I can put some dummy and then continue, I will have this. So, that is a bigger advantage of having this contiguous allocation. The third important thing is that if I want to allocate, so if you look at C or C++, I could go and access one particular byte, random access file. So, I can go and say I can access byte number 100, byte number thing, I can go peek. Okay. Now, if I want to do such a thing, contiguous allocation is very easy for me. So, if I want to, so each block has 512 bytes, if I want to access the 514th byte, then I can directly go to the second block and look at the second byte there, if each block has 512 bytes. So, random access becomes very easy. So, there are the pros and cons of contiguous allocation. So, if I want to access some byte there, so the block to be addressed would be q plus qth block and rth entry within that block. So, I can just do q plus starting address. So, that will be the block, within that block I need to access the rth byte. So, I have a file of say n blocks, say if I want to access the kth byte, I can generate which block that kth byte will belong to, that will be k by 512, and k remainder 512 will be the displacement within that block. So, I can generate this q and r and then quickly access it. This is very simple. This explains you why contiguous allocation can become a issue, right. Now, you see there is one file which is occupying 0 and 1, another file which is occupying 6, 7, another file which is occupying 14, 15 and 16, 19, 20, this whole big. Now, if you see there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 blocks that are free. If I want to have a file which is asking for 10 blocks, I can't allocate it now, I need to go and so there is already some fragmentation 2, 3, 4, 5, 8, 9, 10, 11, 12, 13 and so. So, So, I have 13 blocks free, but if I want a file which will occupy 10 blocks, I can't allocate, I have to now go and compact this file system. So, this is another, so files cannot grow and we will land up with lot of fragmentation. Now, a linked allocation is you start from somewhere. So, I start, this is a file called jeep. So, this is a file called jeep, it will start with 9, then there is a pointer there which will take it to 13, from 13 to 16, 16 to 1, 1 to 2, 2 to 18 and then 26 and so on. So, it will end up 25 and so on. Now, the biggest problem is if I suppose I go and cut this link, right, a virus can just go and cut this link, suppose this corrupt this particular block, then the entire file major part of the file is lost. And suppose you have an encrypted file where this is or a encoded file or a compressed file where the compression is lossless, then I need the entire file to regain the file and completely it is gone. So, the amount of file, so this is failure rate from a virus perspective, this is not going to be a very encouraging thing for us. We may lose more data by having a linked allocation. The second thing is access. Suppose I want to access the 5th block, I have to go like a linked list. So, it will take more time for me to access. So, from a performance point of view, from an access point of view and also from a security point of view, linked allocation is not that much desired. So, I had pros and cons of, but the file can grow in this case. So, I had pros and cons of contiguous allocation, I have pros and cons of linked allocation. So, let us take the best of both. So, I have this what we call as this indexed allocation, where given a block I compute a hash function and I go, or I just say that the block 1 is stored at 9. So, I maintain an index. So, I will say block 1 is stored at 9, block 2 is stored at 16, so on so forth, so forth, right. So, by this if I want to access block 2, I can go to say block 0, block 1, block 2, I can go to the 1 and this is block 2, like this block 3, etc. So, I can go for everything like this. But then if a file occupies 4 MB and each is half 512 bytes, the number of blocks it will occupy is quite high. So, the index itself will become a bigger file for you to manage. Okay. So, just an indexed allocation, the point is this can grow. I could have random search and I could have also growth here, but the thing is the size of the index will become quite large. So, that is why they have a Unix has come out with a unique scheme. It is a combined index plus storage allocation. So, it is a multi-level index. So, this is the Inode. So, as I told you, this is an identification node of a file, wherein some of the blocks are direct blocks. So, blocks say, let us say block 0 to say block 9, just for the sake of this, they are direct blocks. So, when I take a file, say the first 9 blocks, if I want to access any of the first 9 blocks, I come to this inode, go to this entry and go to that block and get the data. Then from 10th onwards, I do something called single indirect. So, if it is in the 10th block, I go here and this will have a point to a block. In this I will store information. So, here 0 to 9, in this entry I will store from 10 to say 100 or whatever. So, if I want to access the 10th block, I come here to this single indirect stage, I go here into this, suppose I want to access the 11th block for example. So, I come to this single indirect, go to this place and here I will look at the 11th block and that 11th block data I will access. So, let us say this will handle till 10 to 100. So, 101 to 5000 I go and do this double direct. What is double direct? When I say 101 I will go here, that will have a set of pointers, from there I will go here and so 101 to say each can store 200 like that, 201 to 300 like that. So, some 4901 to 5000 will be stored here. So, if I am falling within 101 to 5000, then I go to this block, then to another, this will give me a pointer to a block. From there I will go in that block 101 to 200 will be stored, and 201 like that, that will have 100 blocks, right. So this is how I access. Then there is triple indirection also. So if I am accessing the first few blocks within a file, that will be very quick for me, but if I start accessing something beyond that, I will go to single indirection, then to double indirection. So by this, if you see, in a single inode of a very given fixed size, I could store information about the entire file, which is very huge, and that information is there in the inode, then it is spread across several blocks, as you see here, this block, this block, this block, all of them store information about data, how data is organized, right. By this, and these are all the other things that I am marking now are all the data blocks, right. So in this structure we have one parent structure which we call as the inode or the identification node, which contains details about where the data is stored in this form. For the first few blocks, it has a pointer to that data block itself, which is called direct blocks. Then there is a single indirect where it points to a block which has information about the data. Double indirect, it points to a block which again points to a block which has information about data, as you see here. It points to a block which points to another block, set of blocks which has information about data. Triple indirect, it points to a block which has point to a set of blocks which again point to set of blocks which will have information about data. By doing this, please note that a large file, the complete detail about a large file could be captured in this scheme. So that is very, very important. So this is a combination of indexed allocate or hierarchy of indexed allocation. The other important thing is the free space management. How do you manage free space? One of the ways by which I could end up with a denial of service on a server is to go and meddle with your free space management. As long as a new process wants to come in, if you do not find free space, your system basically hangs, it basically rejects that process, right. So there are different varieties of free space management. One of this is a bit vector, which says that for every block of free space management on your disk. So I can't basically even write a file into a disk, right. So when a process gets into execution and it needs to open a file, if it cannot find a file enough free space, it cannot basically store. You can't copy, right. So nothing could be possible. A denial of service can basically happen with this free space management. So a disk has say n blocks marked 0 to n minus 1. I have n bits, and that n bit, if bit, so for every block I have a bit. If that block is 0, that means it is free, and if it is 1, it is occupied. Okay. Some of the drawback of this is that if I have lot of blocks, then I need lot of bits to maintain that. So there is a need for an extra space, but it is easy to get contiguous files. Suppose I want to maintain a contiguous file allocation, contiguous space allocation on your disk. Now suppose I want 10 blocks to store a file in a contiguous way, then I should go through this bit vector and find out 10 consecutive zeros. If I find 10 consecutive zeros, that means I can allocate that file there. So to find out contiguous space in the disk is very easy in the case of this bit, and I could also maintain a linked list which will tell you which are all the blocks that are free. Okay. So that is also easy. Then I can also group, I can count, all these things, because it is all bit operation, so I can do lot of things on this. The point is that this bit map that we have talked of, which basically indicates how is free, what is the free space available. A copy of that bitmap will be part of a memory, because whenever I want to create file, I will not go and read from the disk, I would love to read it from the main memory. So this bitmap or this file free space management structure is a part of your in-memory disk. So one of the things, the major challenge, the moment I have two copies, one at the disk and one in the main memory, there should be a coherency. It should not be that in the disk it is said it is free, but in the main memory it says it is occupied, or vice versa. So these type of coherency issues has to be handled, and so one of the important aspect of operating systems is basically to handle this type of coherency issues between an in-memory structure and a on the disk structure. So, there is from the disk the details are copied into the main memory, and for performance issues, as I repeated earlier, and that coherency should be maintained. So, there should not be some bit set to 1 here, equivalent bit set to 0 there, vice versa. So, normally a free space will also be maintained as a linked list. So, whenever I need a file, I can just go to that free space listed. Now, I want so 2, 3, 4 and 5 are all free in this case. So, I need say 2 blocks, I will go to the free space, I will get that 2, and then I will make the head now point to 3. So quickly I can retrieve space. So, this is another thing. So, what we have covered so far in this 12 modules are the basics of operating system, which is necessary for you to understand administration of operating system in a great detail. And I also gave some amount of notions of information security, which you need to keep in mind when you start administering these operating system modules. So, we have done a very quick introduction to these aspects. It is no way exhaustive. Operating system itself is a 1 semester course in any of the BTech program. We have just spent 12 modules, 3 modules per hour, 4 hours, which is just 1/10 of what we get, 1/10 or 1/15 of what we get when we teach this operating system as a course. So, I expect that you go and look at information security 2 course also, where you get lot more details about, and I have given pointers wherever you have to go and look into information security 2 course, and also some more reading material of standard textbooks, which will make you good in operating system. But as far as this course is concerned, for the assignments and also your exam and your certification is concerned, whatever I have covered here is sufficient. Whatever I have given as pointers is for you to get more in-depth knowledge about this whole stuff, right. So, that is very, very important. I am sure none of you are going to do this course just for the sake of certification, because the certification is important, but I am sure your major interest in doing this course is for gaining more knowledge and in-depth understanding. So, we have given those pointers. I hope you follow those pointers and do much more in-depth study even after you complete these assignments and finish this exam for this course. But whatever I have told here in terms of extra study and extra look at is very important when you want to become a security engineer per se. So, that pointer also we have given. So, with this my colleagues Mr. Vasan and Mr. Dr. Shankaraman will be covering some of the aspects of administration of the operating systems, typically a server environment and the network environment. I wish you all the best, and see that many of you get certified, and I also look forward to lot more interactions on the support portal where you have queries. We have very good teaching assistants, Dr. Subhadra and Mr. Prasanna Karthik, who will be also responding to your queries. I want to see lot of queries coming up and lot of discussion happening in this. This is a very, very important field, and there is a great future both economically and academically and research wise. So, people who are wanting to do some research program like PhD or MS, information security is a very, very important area. And of course, if you are looking at the, this is a Saraswati component, if you are looking at the Lakshmi component, of course, there is lot of job opportunities that will come up very shortly with lot of digitization happening across the world and importantly in our country. We going to cashless economy, I think information security will play a very crucial role, and taking these type of courses very seriously will give you a lot more secure future for you to have a very good future there. So, I hope this course will be a good stepping stone in that direction. Thank you very much.